Hello and welcome to today's webinar. This is Mark Flantier of Enercon Industries, and we appreciate you joining us today for Achieve a Perfect Seal. Please note that this webinar is being recorded and will be made available to all registrants as soon as it is posted online, usually within 24 hours. You may ask a question at any time during the presentation by typing it into the question tool provided on your screen. Our panelists will answer questions at the end of the webinar. If there is not enough time to answer all the questions during the webinar, our panelists will follow up with you. Today, we are very fortunate to have two packaging industry veterans who are experts in cap sealing. BJ Raddick has been with the Sealy Group for 30 years. He is currently a regional sales manager with key account responsibility coast to coast. He is an active member of the packaging industry and has been a keynote speaker at many events and associations throughout his career, including the National Association of Container Distributors, Institute of Packaging Professionals, Philadelphia Drug Exchange, and many more. Ryan Schulke is Enercon's Vice President of Sales and has over 20 years' experience in the packaging industry. His passion for customer success is truly contagious and has added to Enercon's reputation for creating remarkable customer experiences. Ryan is an active member of PMMI and several industry associations. You may contact BJ or Ryan directly through their email or phone numbers as shown. In addition to the presentation slides and webinar recording, everyone in our audience today will also receive access to Enercon's Getting Started with Induction Cap Sealing ebook, Sealic's Technical Guide to Successful Sealing, and Enercon's Cap Sealing Setup Log and Checklist documentation. Those of you in our audience today will also receive a personalized certificate indicating your participation in today's webinar. Today's presentation is all about providing you with the insights you need to achieve a perfect seal. Topics our presenters will cover include the benefits of induction sealing, mastering the variables of pressure, heat, and time, keys to selecting the ideal induction liner, how to set up an operating window, troubleshooting tips, and we'll leave time again at the end for questions and answers. Let's start the presentation with BJ Raddick talking about some of the benefits of induction sealing.
Thanks, Mark. Thanks, Ryan, and thanks to everybody out there for joining us. Let's talk about the benefits of induction sealing. First, there's leak prevention. With the incredible growth in e-commerce, leak prevention has become a major focus in packaging today. They also provide consumer confidence, tamper evidence. I'm sure most of you will remember in 1982, 7 people died in the Chicago area because they ingested Tylenol that was laced with cyanide. And afterwards, induction sealing became the industry standard form of tamper evidence. Added barrier the foil layer provides extends the shelf life of the product. It also provides safety and security, protects the efficacy of the product, and also seals in factory freshness, prevents product contamination. It also helps to retain the aroma and can also be used for security or brand protection. So I mentioned leak prevention. Major and very, very essential businesses have each kind of highlighted the use of induction seal as a preferred method for ensuring packages do not leak in transit. FedEx and UPS both promote the use of induction seals, and Amazon has established detailed guidelines and specifications which do include an induction seal. So 3 of the key pillars to ensure a perfect seal are PHT, or pressure, heat, and time. Understanding the induction process is important in choosing the right induction liner. Pressure, heat, and time are the variables in this process. The pressure piece is the pressure between the liner and the container surface, which is controlled effectively by the capping equipment. The heat is what helps soften and melt the heat seal surface of the liner and is controlled largely by the power setting on the induction heating equipment. And time component refers to the time the foil is exposed to during the induction heating process. So let's talk about pressure. Pressure, or proper pressure, can only be achieved by using the recommended amount of application torque measured in inch-pounds. Every cap size has a recommended amount of application torque. I've seen various torques that change a little bit here and there, but I cannot really emphasize enough how important consistent application torque is and operating within the recommended range to get a successful seal. If you cannot control application torque, or if you have variability in the process, you will have inconsistent seals as a result. All right, heat. Obviously, heat refers to how hot the foil gets during the sealing process, and we'll talk a little bit more about that in detail, but generally, if the settings are too low, you'll get inconsistent seals or leakers. And if the settings are too high, you can scorch the material, you can burn it, which will result in an off odor, or you can compromise the protective heat seal film and barrier layer, which could result in corrosion. Next, we've got Father Time. So time is referred to as dwell time, and that's the duration the foil or package spends in the electromagnetic energy field. And Ryan, can you explain how to control or change the dwell time a little bit?
Yeah, BJ, this is an important piece. It really hits on both the heat and the time component, because you've got a couple of ways you can adjust. If you want to adjust the time, maybe you need more sealing energy applied to the induction heat seal to get the proper bond with your container. You can do one of two things. You can increase the output power of the machine, or you can lower the line speed. Ultimately, that means that you're increasing the amount of time, if you're lowering the speed, that it's under the sealing heads. The flip side of that is, if for some reason you need less energy to seal your container, you can lower the output power of the machine, again, that heat component of the variable, or you can increase the line speed. Now, probably most often you're going to either increase or decrease the output power of the machine because your line speed may be fixed for the other machines on the line, but you do have the ability to vary either line speed or sealing power to increase your sealing output.
Right. So we kind of set the table for the variables. We talked about pressure, heat, and time. Let's talk about the liner selection process and how to select the proper induction seal. So one of the first questions we would typically ask when someone asks which material they should use for an application, first is, what's the product being packaged? Is it a food, a beverage, a pharmaceutical, chemical, etc.? And we need to know if there are any aggressive or volatile products that might require a barrier layer to protect the foil in the event of corrosion. Even many food products, like simple ketchup, would require a barrier layer to prevent foil corrosion. So after we've identified the product, then the next question is, what's the container resin? What are we actually going to seal to? Is it polyethylene, polypropylene, PET, or glass? Now, if the container is glass, the glass must be treated on the lip of the container to aid in adhesion. And we've seen a resurgence in glass in some markets. Go to the next one. So as we've seen a resurgence in some markets, gourmet spices, mayo, nut butters, and now cannabis are all using glass in addition to plastic. But Sealy has developed a family of induction seals called GlassFuse, and there are three types. There's the Delta Seal 9000, which is a board-backed two-piece induction seal. We've got the Lift and Peel F as in Frank, which is also called LPF. It's an easy-to-remove tabbed product. And then third, we've got the Unigard 925, which is a polyolefin foam-backed one-piece induction seal. So after we understand the product being packaged, the container resin, the next question is, what kind of removal characteristics are you looking for? Peelable or clean peel? Typically food, beverage, cosmetic would prefer a clean peel material, or a peelable tamper-evident structure that would be easy to remove, but still leaves a tamper-evident layer on the bottle, or a true weld or tamper-evident with easy entry that you can puncture with your finger, or possibly a true weld that is puncture resistant. Basically, you need a knife or a kitchen utensil to breach the membrane. And then there's a unique category, which would be a true weld, yet peelable, using a lift and peel or top tab that is easy to peel and still leaves a tamper-evident ring on the lip of the container. So the next question would be, what kind of backing is required? Do you need a single element or one piece, which would basically be a paper, a board, or a foam in different thicknesses, permanently bonded with adhesive to the foil, and nothing is left in the closure for resealability? Commonly used in peanut butter or snack applications, that type of thing. As a side note, these one-piece materials can be double lined with a separate liner to stay in the closure for resealability. Then you've got kind of the opposite of the one-piece, which would be the two-piece or separating material. The backing here is typically pulp, again in different thicknesses, and that backing is typically wax bonded or temporary adhesive, wax bonded to the foil, which melts and is absorbed into the pulp to achieve proper separation during induction. And then in some cases, you may want a high barrier reseal material to stay in the cap after the foil is removed. We refer to it as foil seal E or foil seal LE. The backing can be pulp with a protective facing or a foam. It's typically used in the pharmaceutical industry and in some chemical applications. And then the final consideration would be removal feature. Do you need some form of a tab? The most common that you see out there would be either a tri-tab or lifting peel, but the tri-tab would be cut by the closure manufacturer during insertion. The tri-tabs do provide some liner retention to prevent the liner from falling out, and do provide the consumer with, a small piece of material to kind of grab onto and remove. So it does provide some consumer removal feature. Then you've got the more consumer convenient tab system, which is a half moon tab that would be similar to the foil seal, the lift and peel one piece, or the top tab two piece. So that covers the material selection guide, and we'll go through the equipment configuration. Ryan?
All right, BJ, this is Mark. We're looking for Ryan to reconnect here. I can pick this up from here. When we talk about equipment configuration, the first thing we look at is matching the sealing head to the cap foil configuration. What you're looking at here is the power supply of the induction sealer, then the interface, and then the sealing head down here. So there's multiple power supplies and multiple sealing heads, which could be applied based on the application. one of
Thanks
the
for stepping
influence.
in for me, Mark, there.
Oh, you back? All right.
I'm back. All right, so I want to start by talking about some of the key influencers that come into play when we're deciding what power supply and ceiling head may be right for your application. And two questions we're always going to ask right away is, what is the cap diameter or diameters that you look to be sealing with your products? Sometimes it's easy and it's, hey, we're only sealing one package on a line. Sometimes you may have 2 or 3 or 4 or 5 or shoot even 10 packages. And we're going to want to know what the diameters of each of those closures are so we can choose the right machine for you. Likewise, we're also going to want to know what the style of closure may be. Is that just a flat continuous thread cap like you see with the bigger blue cap kind of in the back? Or as you look at the 2 white caps here on the left, those are child resistant closures. Or do you get into some sort of dispensing feature like you might see on a ketchup bottle or a mustard bottle? Those all come into play, and we need to understand what the sizes are, what the shapes are, to help make sure we get you to a point where you can make sure you're achieving a perfect seal every time. So we look at that for a couple of reasons. One, we're going to look at it from the diameter, specifically to look at, believe it or not, a larger foil can sometimes be easier to heat than a smaller foil can. You sometimes would seem a little counterintuitive, but you've got more metal mass to couple into on a larger diameter foil than smaller. Likewise, the package of mustard here is a really good illustration. If you see the top arrow points to the top of the cap, and that's what's going to be closest to the induction sealer itself. But the bottom arrow shows where the foil is actually located in that package. And the further away you get from the sealing head on the induction sealer, the more difficult it is. The induction sealing energy that we're creating here actually dissipates with the square of the distance. So it's an exponential decrease in power. Now, we've found ways to get around that, and we'll talk about those here next. So other considerations that you want to look at, there's cap considerations, liner considerations. BJ talked a bit about that you've got single piece liners or 2-piece liners that have release characteristics. Those are things we're also going to want to know. They play a role in sizing the machine, but also the geometry of your bottle. If you look at the big blue bottle in the back, that's what we would call an F-style bottle. You'll see that the handle of that is typically on the same plane as the top of the closure. That's going to dictate a specific configuration on the sealer. Some of the other things that you see is think about going to the grocery store today and seeing and going and shopping for orange juice. There's been a big shift in that space to go to a clear kind of carafe style package that has a larger diameter closure, but when you take off that closure, you'll see that the foil is actually smaller. So we've got to, if that's the case, we need to know that as well. All of these things come into play. If we can see samples of the packages or drawings of the packages, that's a big help in the selection process of an induction sealer. What we're getting to is we're trying to get to what sealing head is best for your application. Again, you could have one cap that you're trying to seal, or you could have 5, 6, 7, 8, 9 caps that you're trying to seal, and we're going to take all that into consideration. Our sealing heads really kind of break down into 4 categories. The picture in the upper left is what we call our wide flat style sealing heads, or flat style sealing heads. You see the white arcs coming out there. That's a simulation of what the electromagnetic field that we're creating looks like on these wide flat sealing heads. They're typically used for closures that are relatively flat and 63 millimeters or larger. As we move to the top right, this is going to be an example of either our wide or narrow tunnel sealing heads. These are some standard systems that we use quite often. You see there, those arcs are coming out from the center, just like they do on the wide flat, but the radius of that arc is much smaller. It's going into a smaller area. We use that to seal, let's say, probably a 24 millimeter closure on up to a 53 millimeter closure very, very efficiently on those. The bottom left shows an illustration of what happens with our deep tunnel sealing heads. So we'd use a deep tunnel sealing head when we've got a smaller diameter closure. Think of maybe an 18, 20, 22 millimeter closure. Or when you have those applications like that mustard bottle we looked at a couple of minutes ago, where the spout is taller and the foil is further away from the top of the sealing head. The first two pictures we looked at were heating from the center and going out. On a deep tunnel coil, we're actually heating from the sides to get as close to that induction foil as we can. The final picture on the lower right is one of our all-in-one sealing heads. And this is one that is very useful in many applications when you might have a number of flat or continuous thread caps. And they tend to be a very useful sealing head for co-packers and just people with multiple packages. One of our latest innovations on the all-in-one sealing head front is a very unique design. It's actually unique to the market in that we are able to create a repeatable setup. Many of the all-in-one sealing heads, in fact, some of our former designs, were really an infinite adjust, which was great that you're able to infinitely adjust. Now we go through and we've got 4 positive stops that we'll set up. This allows your operators to make sure they're setting it up consistently each and every time. And as we talk about the process of establishing your operating window here in a couple minutes, consistency is one of the keys of the process. So this is a really unique feature here, and our customers have really shown that they love it because of those repeatable results. So when you're looking at the sealer side of things, we focused a lot on the sealing head so far. The sealers come in many shapes and sizes. On the top left, you'll see our SuperSeal Max, which is used in high-speed applications. A great system. Again, you're probably talking in the hundreds of bottles a minute. When you move to the upper right, you'll see our SuperSeal Touch. Those machines look very much the same. Their operating systems are very similar. Just going to have, kind of medium speed applications with that. The lower left-hand image is our new SuperSeal, newest SuperSeal. We've had a SuperSeal model for the past 20 years or so. It's been a tremendous product, probably the best-selling, most used induction sealer in the world. We've updated that to add some additional features, so that's new to the market in the past couple of months. And then for manual handheld applications, we have our SuperSeal Junior. This, again, is a great seller. It's great for people who may just be starting out in induction sealing. It may be, lower production volume, but high value materials. One of the places that we see a mix of these systems used would be in the mail order pharma business. They'll often use an automated system like our SuperSeal Touch to take the high volume prescriptions that are going through, and our SuperSeal Junior would be used on those that need to be manually verified or maybe have unique designs on the packages. So BJ mentioned it earlier when we talked about the pressure, heat, and time component. We can do a very good job of selecting the right induction sealer, making sure you've got the right sealing head, getting your operators trained to set up the system consistently. But if you forget to make sure you've got that same diligence and setup with your capper and you have inconsistent torque, you're going to have challenges making sure you get that proper seal every time. The best example I've got to share with you today is one that I learned very early on in my career. Is we went to a customer who wanted us to come take a look at the sealer and said, "Hey, I'm getting 12.5% failure," and we were alarmed. That's a pretty high failure rate. So we went in and we looked. The sealer was set up properly. Its operating window was set up properly. We knew that the machine was working correctly. So we had to look, was it a material issue? Nope, that all looked good. Well, what we ended up finding is that they had an 8-head rotary capper which if you look at what 1/8 is, that is 12.5%. They actually had one of those 8 heads not adjusted properly and not applying enough adequate torque. So can't really illustrate enough how important it is that you're getting consistent application torque to get that pressure component of the pressure, heat, and time equation set up correctly. So now we're going to move into how do you establish an operating window? How do you do that successfully each and every time? You're going to see we've got a continuum here. You can get to a point where, hey, we're getting no seal, maybe a partial seal. You move into a range where, hey, we're really getting a good seal. And then on the far end of the range, you get to the point where it's overheated. That's typically indicated by a wrinkling of the foil, or you can see in a two-piece liner application, maybe you've got some scorch marks on the liner that's retained in the closure. So why is it important? Why do we talk so much about an operating window? It's something that for us, our sales and application team is always working with folks to come in and train operators, try to set up a procedure. Because if you go through and you set up a proper operating window, you are going to maximize your opportunity for success. There's no other thing you can do besides making sure you're in the middle of your operating window to compensate for variable changes. You're going to have slight variations on cap torque. You're going to have bottles that stray maybe a little off center on the conveyor. You might have a little up and down on your line speed, and the foil height may vary a little bit. You may have a bit of variation within specification on your container height, and that will vary the height. But if you set that proper operating window, you really minimize the chance of having any issues with these cases occurring. So the first thing you're going to want to look at when you're setting up a machine, first piece is going to make sure that your bottles are traveling right down the center of the conveyor. You look on all of our sealing heads, you're going to see on the side, they have a little sticker that says center line. You want to make sure that the center of your cap is going right down that center line. On our Super Seal Touch and Super Seal Max systems, we actually have an option that can have a sensor shine a red light down so you can see it not only when you're setting up, but if you have an operator walking by the machine, just a quick verification that, hey, that red light's right down the center of the package. The other thing you're going to do is you're going to make sure that you have a consistent gap between the bottom of the sealing head and the top of the closure in your package. What we provide with every system is what we call a gap gauge, kind of a feeler gauge. What that is that's 1/8 of an inch or 3 millimeters thick. You're going to take 2 bottles or 3 bottles, put them under your sealing head, put that gap gauge on top of those bottles, and you're going to simply lower the sealing head down until it just starts to touch. It's kind of like a feeler gauge. You should be able to just feel a little bit of friction between the top of the caps and the bottom of the sealing head on that feeler gauge. If you've set that up right and you do that every time, that's a piece that will make sure that that gap piece is set up right. It's a piece that come with every machine. If you ever need extras, reach out to me, reach out to anyone on our team. We're always happy to send those out and get you more for your team. So the first step you're going to do in determining your operating window after you've got your center line established and you make sure you've got the proper gap between the sealing head and the top of the closure is you're going to pick a percentage to start at. For this example, we're going to say, let's put it at 40%. Let's take a bottle and let's run it through. You set your line speed at whatever you're going to run it at, run it through at 40, and you know what? We didn't get a seal. All right. Let's go through in the next stage and let's increase it by 5%. Again, run the bottle through. Yeah, nothing yet. We're at 45%. Let's go ahead and run another one through. All right. Now we went up to 50% with another 5% gap, and it looks like we're starting to get a good seal. Now we're going to hone the process in a little bit. Now we're going to start going up in 1% increments and keep increasing it till we see, yeah, we really think we've got a good seal here. You've done that and you've established, all right, 58%, you've got a good seal. That's where it started. So now again, we're going to start increasing. Now we're going to start going up in 5% increments again. So we'll go up. 58 was the start. We went to 63. We've still got a good seal. Let's go up by another 5%. Now we're at 68%, and we can tell the liner's wrinkling or there's a little burning on the retention liner. All right, now what we're going to have to do is we're going to have to start backing it down. So we do the same thing we did when we started to see that partial or good seal. We start taking it down in 1% increments. So we went down to 67. We keep going with that. And what we found is that, all right, we're still getting a good seal at 65%. So now what we've done is we've established that operating window that we're going to see between 58 and 65%. So just a kind of a quick recap here, what you want to do, you want to find the minimal power level that produces a good seal. So again, you're going to pick up output percentage. You're going to make sure your line speed is set at what you're going to run production at, and you're going to run a bottle through. In this example, we say 50%. It could be 40%. What is really important is that you're recording this information each and every time. And every time you go to run the product, you want to run through this process again, where you go from no seal, increase by 5% increments until you kind of straddle that line between a partial seal and a good seal, go up in 1% increments. All right, I got a good seal I'm happy with. Start going up in 5% increments. When it overheats, you bring it back down in 1% increments. And always remember that as you're doing this, the number one reason for bad induction seals is a lack of sufficient application torque. So if you're seeing inconsistencies, make sure you're doing some torque testing of what your removal torque is coming out of your capper. So in the example that we gave, we started where there was no seal. We started at 40%. We increased. We found that, all right, we're starting to get a good seal at 58%. We're able to go all the way up to 65% on the machine before it starts to overheat. So now we've got this window. We've got the 7% window that we can work in. My typical recommendation is put yourself somewhere in the middle. Go 61%, 62%. Somewhere in the middle usually helps. Some people like to run a little bit lower. Some people like to run a little bit higher. That's really a decision that you need to make in your operation. But if you know you're getting good seals in that range and you put yourself in the middle, that's probably where you're going to give yourself the best chance of success. So once we've set that up and once we've got an operating window set up, the other thing that you're going to want to think about in helping give yourself the best chance of minimizing any failures in your product is making sure you're incorporating some sort of inspection component as well. And this really starts at a couple of areas. As you're selecting your cap and liner combination through your closure supplier, you want to make sure that they've got a good quality control process where they're inspecting to make sure liners are in the caps as they ship to you. We also include foil detection as an option with our machines, and it's a really good safeguard because we can reject a bottle off the line that doesn't have foil. If it doesn't have a foil in the cap, there's no way it's going to seal, so it's good to get those off the line. The other thing you want to make sure you do is you're always detecting for stalled bottles as well. So this is the case. An induction sealer is really a machine that is going to heat the foil as it's going underneath. If a bottle gets stuck underneath the machine or backs up into the machine, you want to have that safety component there where you're able to shut the machine down if a bottle stays under the sealer for too long of time. So when we look at troubleshooting tips, you're going to look at those with no seal. All right, what's the characteristics of that? There's no container bonding. Partial or weak seal, all right, you might see half of a seal or a partial seal, or maybe it peels off a little too much. An overheated seal, you're going to see wrinkling of the foil material or the backing layer. You'll often, BJ mentioned an odor, you certainly don't want that, or scorching or burning on the pulp board. And that that overheated piece is really important because if you do overheat it, you can impart an odor in your product as well, which is certainly something you'll not want to do. But if you look at all of these, application torque comes into play, line speed comes into play, making sure things are centered. All of the things that we talked about today, you can see are areas where you can find problems. And if you take care of those, you will make sure you find a way to have a good seal every time.
All right. Thank you, Ryan, and thank you, BJ. Before we get to our audience's questions, just a quick review. Benefits of induction sealing. They include leak prevention, shelf life extension, tamper evidence, consumer confidence, and they can also be used to meet e-commerce packaging requirements. Very important in selecting the right induction seal material for your application, and Sealig has several ways that they can help you with that. You need to be able to master the critical induction sealing variables, pressure, heat, and time. That combination is going to come up in the operating window for your applications. And it's important to set up the operating window and make sure that you train your operators and document your processes. And again, we've hit this a few times. The number one cause of induction seal failures does tend to be insufficient application torque. So definitely don't forget about the capper. We put together this graphic, and really, just like when you build a pyramid, you have to have a strong base. And if you think of achieving a perfect induction seal, you have to make sure you have equipment that's going to match the application. You're going to have to make sure that you have quality and consistency in your caps, containers, liners. You want to make sure you train your operators. You want to set that operating window, and you can then add cap inspection on top. If you don't get those things right and you add cap inspection, you're just going to be rejecting a lot of containers. So really spend time to train your operators, make sure that your processes are well documented and that you've got the right liners, the right caps, and the right equipment for your specific application. With that, we're going to move on to our question and answer session. Again, we'll get to as many questions as we can. If you want to reach out directly to Ryan or BJ, you certainly can as well. The first question we have is, does an induction seal meet Amazon's requirements for shipping liquids?
Yeah, this is BJ. I'll take that. It absolutely does. Amazon has clear directives in their recommendations and specifications, and induction sealing is one of the key areas that they've highlighted that will prevent leakage. So yes.
And BJ, to add to that, we do have a specific webinar that talks about e-commerce and packaging. That if you take a look at the webinar section of the Enercon website, there is a specific link in there for an e-commerce webinar as well that might tell you more.
Yeah, that's great, and we do as well. We've done several webinars focused on e-commerce. All of those are available on our website as well. Thanks.
Very popular product nowadays is hand sanitizers. Can hand sanitizer containers be heat sealed?
Yeah, I think there's a couple of pieces that you're going to want to consider there, BJ. I'm sure there's a foil component to that you're going to want to make sure you're choosing the right foil.
Yeah, absolutely. The simple answer is yes. Hand sanitizers can be sealed. They are being sealed, and the activity is skyrocketed, obviously, and choosing the proper material for hand sanitizer is important. I talked in the presentation about the requirements of a barrier layer for aggressive or volatile products, and hand sanitizers have a significant amount of alcohol, obviously, and they would need that barrier layer to protect the foil from corrosion. We'd be happy to help you with the material selection.
And likewise, there's going to be components as you're choosing a machine to make sure you're choosing the right machine with the right features as well. So it's really both a material and an equipment perspective that you want to make sure you're talking about the Sealig team and the Enercon team about.
I have a question here, and it's really from a consumer perspective. Their person encountered an easy to remove peel. I think it's a lift and seal, but it was tough to remove on a vitamin bottle. And what would be some of the factors that the manufacturer would have encountered that would have made that more difficult to remove than it should have been?
I'll comment first. and then Ryan can add on. As a consumer myself, I've seen difficult to remove packages with lift and peel. We, with the Sealy Group, have taken a very proactive approach and tried to reach out to the brand owners that have products out there in the marketplace that are in fact difficult to remove, because by default, the lift and peel should be easy to remove and provide that consumer convenience. The bottom line is, if it's too hard to remove, it's a clear indication of overheating. We talked about all of those variables, pressure, heat, and time, but it's probably a combination of variables, but the seal is not being run properly. So if the brand owner takes the time to run their lines properly, to set up their lines, then they can achieve an easy to remove seal.
Yeah, and that's, BJ, I think you covered the main points there. I think what's important to know is that sometimes what we see from an equipment side is that, well, if, we looked at that operating window that said 58 to 65%, well, shoot, if I put it at 65%, maybe 70% is better. And the reality is you do straddle that line of then overheating that material, sometimes not to the point where you're burning it, but where you're really eliminating the design of that heat seal material where it's easy peel. So that can be an operator training component. One of the things that we've done with customers who have that problem is on our Super Seal Touch and Super Seal Max systems, we actually have two features that can help you with that. One being a recipe control, which allows you to pick a recipe and have the power locked in on that recipe, but also operator lockout's another feature where you can require a password to change the output of the machine as well. That's another way to, if it's an operator issue, that you might be able to solve that issue as a packager.
Thanks, Ryan. We have a question on, there was a reference to treatment on glass. Can you talk more about the type of treatment that you would recommend?
So this is BJ. When sealing the glass, there's always been a certain degree of mystery. When we talk about treated glass, all glass is treated during the manufacturing process. There's a hot end treatment and a cold end treatment, but you really need to kind of drill down more deeply. And the question is, how is it treated and treated with what? Typically, out there in the marketplace, you've got a hot end treatment, which would be tin oxide, and the cold end treatment, which would be oleic acid. However, there are some other derivatives used out there in the marketplace. I know polyethylene is used as a treatment, but it's important to note that the treatment must be on the lip of the container. Many years ago, when metal closures were used on glass, the treatment was set up so that the tin oxide was not allowed to get up on the lip of the container because it created corrosion, foil corrosion of the metal closure. So now we're saying we need that tin oxide up on the lip in order for proper adhesion. I would say that we're working closely with glass manufacturers to ensure that the ideal treatments are used. And as I said, there are some other derivatives aside from the tin oxide, oleic acid, or polyethylene used out there.
Thanks, BJ. Ryan, we have a question on, do wattages of sealing units vary? And if so, how do they affect settings?
Yeah, so for many years, induction sealers were rated by the kilowatt output of the machine. And that's a piece that was probably more consistent amongst manufacturers as you go back to, probably the 80s and into the 1990s. So it's been quite a while where that hasn't been as relevant. When air-cooled systems became the norm, what we were able to find is that oftentimes you were able to get better performance out of an air-cooled system than an old water-cooled system at a lower kilowatt output. So what we've really done is we've worked hard to optimize our sealing head configurations to make the most efficient machines as possible, use the least amount of power, make them a bit more green from that perspective. And what we found is that while, yes, there is an output of every machine, comparing a machine to machine really isn't as valuable today as it once was. What we'll do is we'll take a look at what's the diameter of closure you have, what's the style, and how fast do you want to run it. That, along with what's the material you're using, we can go in and see, all right, what speeds should we be able to run on that application? There are things that influence that. You'll get a product being filled at room temperature. We'll seal at a different output on the sealer than something that's hot filled at, say, 180 degrees Fahrenheit. When the product's warmer, it's going to usually require less output on the sealer. Or if you get a cold fill product, maybe a gallon of milk, let's say that, that's obviously filled a lot colder, down in the 30-degree range, well, above 30 degrees, but 30 to 40 degrees. And that is going to require more output power of the sealer. So there's some caveats to that, but the wattage output of the machine really isn't a fair comparison anymore today.
Ryan, can you talk about, is there a recommended space needed between containers as they go through an induction cap sealer?
So with our induction cap sealers, we've designed them that you can run one bottle underneath, or you can run as many bottles as you can fit underneath. We've designed them to be able to handle the load that the machine experiences when the foil goes underneath that. Generally speaking, you probably do want a space between bottles. Specifically when it comes to our cap inspection options, you ultimately need to be able to see a space between bottles to differentiate when a bottle is there or not there. Sometimes you can run the bottles back to back if there's a spacing between the caps or the neck of the bottle. But usually you want some sort of spacing, but it could be, it could be a very small space or it could be a large space, and it can vary. The machine ultimately doesn't care, except when you're trying to inspect packages, then you do need to make sure that there's some space that we can see between them.
I've got a question here regarding the importance of having a completely flat land area, and how flexible is the induction sealing process to compensate for non-perfect landing areas on polyethylene bottles?
That's a good question. They qualified it by polyethylene. Polyethylene is one of the more forgiving resins because you can get some degree of melt of the lip of the container to help compensate for flash or a step at the parting line. It does depend on the method for molding used. We're more concerned about the overall quality than the thickness of the surface that we're sealing to. In today's marketplace, I think a lot of the suppliers of polyethylene containers in general have made great advancements in providing a quality product. Now, granted, there's only so much that the induction sealing process can overcome. But overall, from what we see out there in the marketplace, with proper setup, proper torque, you should be able to overcome minor defects in the sealing surface. Ryan, do you have anything to add?
Well, BJ, I was actually going to ask, what if someone's got a bit of a saddle and a land? Is there anything you can do to compensate from a material perspective? Can you make it a little thicker, or is there anything you can do on that side?
Yeah, it's a good question. Generically, and there are some exceptions, thicker materials tend to be a little bit more goof-proof or forgiving. Again, generally speaking, there are exceptions. So compressible materials can help with that, can help make up for saddles. But equally, proper application torque or almost excessive application torque can compress the material and almost force contact. So we've seen lines operate with more application torque and probably a little bit more power to melt plastic and get a good seal. That's not an ideal scenario, but thicker materials can help address it.
Can you talk about any trends relative to 1- and 2-piece liners and where they're being used?
So 1-piece liners are typically used in the food industry, I'd say food and beverage, whereas 2-piece materials are commonly used in the pharmaceutical industry, agricultural, chemical, some food service applications like edible oils. So snacks, foods, beverage generally use 1-piece. The 2-piece would be used when a reseal would be a functional requirement of the package. So pharmaceuticals, liquid products like chemicals, etc.
Thanks, BJ. Ryan, some questions on is there a max bottles per minute that, say, the Super Seal Touch can handle?
Yeah, I mean, it's going to depend on a couple of things. Number one, it's going to depend on that size and style of closure that you're looking to seal. There's certainly going to be a max that you hit for that machine. Maybe I shouldn't have used the word max. Maybe I should have said maximum. Because when you do hit the higher limit of the Super Seal Touch, that's when you would go into our Super Seal Max machine. If you've got a specific question about a machine maybe that you've got, we can just reach out to me. We can look up the machine, look up the combination, and give you a feel for maybe where you should be able to get. One of the things that we can sometimes do is maybe you've had a package change. Maybe you bought a machine that has a specific sealing head configuration on it, which isn't optimal for your application that you're looking to do now. If that's the case, we can often just change out the sealing head, and guys like BJ and I can probably change them out in 5 minutes. So anybody with any sort of mechanical skill can probably get it faster than we can. That's a way to potentially get more output out of the machine as well.
We have a question. Is it okay to use an empty bottle when setting up the sealer, or do you need to have product in the bottle?
I think it is, you certainly, as you're setting up the sealer, if you want to use empty bottles, and we see people do it all the time just to kind of establish that operating window, certainly go ahead and do that. I think what you want to make sure you do then is run some full product bottles through after you do that, just to verify that that operating window is set up correctly, particularly if you're running either a hot fill or cold fill application, because the temperature of that product can impact what output percentage of the machine that you need. So, oftentimes we see people who don't want to waste product that's going out the door, and we say, go ahead and start with some empty bottles, but make sure you do a check before you go into production. Don't just trust that, the empty bottle is a 100% accurate representation of what you'll get with a full product.
Is it possible to seal mega large caps, 165 millimeter in diameter, for example?
Yeah, when you get that big, typically go ahead, BJ.
Go ahead, Ryan. I was going to say, the largest would be the 120 millimeter is the largest that I've experienced personally. But what about you?
Yeah, I think we see something similar. 120. That's exactly what I was going to say, BJ. Is kind of the top end that we typically see. I've seen a couple push 130 here and there. That's a really big cap. And what you've got to think about is, while you may have a machine putting the closure on to the package, you're probably having a human hand take the cap off. And 120, most human hands that have no problem getting around. If you're going to get up to 165, that's probably using 2 hands to get off, or you got somebody with some really big hands pulling those caps off. it can certainly be done. We can do some things from a machine perspective to get a machine to seal that. It just takes a bit of custom setup to get there.
Ryan, we have a question on what happens if caps are over-torqued?
Well, I think BJ started to talk about that a little bit, and sometimes it's if you're trying to overcome a defection on the bottle, that can be a good thing. But generally speaking, if you're over torquing, you're putting a bit more pressure on points, and you're going to heat probably a smaller surface of the bottle. And I'm guessing, BJ, you can get points where you're going to compromise the laminate structure of the liner as well.
Absolutely. Yeah, I've also seen applications where when excessive torque has been used, it actually causes all of the plastic to kind of deflect, and you can actually eliminate the contact of the heat seal film to the lip of the container because of that excessive torque. So too much torque is not necessarily a good thing. Can definitely create dimensional issues and contact issues.
In sealing food, if there's a high fat content, how does that impact the seal selection?
High fat content really doesn't impact it. It's good to know. As I said earlier, we want to know what product is being packaged, but fat in and of itself is not corrosive. It doesn't create unique challenges or concerns. So my question would be, what else is in the package that could be an issue? But fat is not an issue at all.
When using a retorquer, where is the best placement? Is it after the induction sealer as a best practice?
Yeah, if you're going to be using a retorquer, and
go ahead, Ryan.
Go ahead, BJ.
So a retorquer, they're commonly used for child-resistant closures in the pharmaceutical market and some others. The general rule of thumb is put the retorquer as far downline as you possibly can to give the foil and the heat seal film and the wax, if wax is used, an opportunity to do its job, to cool, to set, to solidify, prior to disturbing the seal. So in a perfect world, it would be far, far downline, but in a practical sense, we understand that it can be a short distance between exiting the induction field and retorquing.
Hey, BJ, have you seen an increase in retorquers, decrease in retorquers? I mean, what have you seen over the years?
Well, it's very, very common in the pharmaceutical industry, and most packages that use a child-resistant feature, the retorquer is used fundamentally so that the child-resistant feature is either re-engaged or it's confirmed that it's engaged and functions according to the child-resistant guidelines. That's a critical piece. And then for non-CR applications, if closures have a tendency to back off as the plastics heat up and plastics then relax, and if you have a significant amount of back off, then a retorquer can help re-engage the cap and prevent the caps from literally falling off in transit. I wouldn't say I've seen more, but I definitely haven't seen less. They serve a purpose, they serve a need, and are fairly common out there.
All right, we are at the 1 hour mark, and we have a very large audience today, and the vast majority of them are still on with us. We're going to continue to answer a few more questions. Do know if you do have to depart here at 11 o'clock, within the next 24 hours, you will receive access to the full recording and presentation materials. With that, we have a question on regarding non-threaded caps. Is there a way to measure torque on a flip-top cap like the Tums container shown? And is it possible to seal containers that do not have threaded closures like lug closures?
Well, I'll
Yeah,
start.
so
Go ahead, Ryan.
all right. So, I mean, the big piece of that is you're asking about the pressure component of the pressure, heat, and time equation. That's the big piece there. And the Tums package that we showed was actually a very unique package where it was designed that closure fit very, very nicely with the bottle. There was a lot of configuration and testing that went on with that package. You'll see snap-on closures that are used in the pharmaceutical industry. Think about the ones where you have to line up two arrows and then snap the top off with your thumb. That's one, again, where you get good engagement between the closure of the liner and the bottle, and that works really well. If you don't have good engagement, if you don't have some sort of pressure between the closure, liner, and container, what you're going to do is you're not going to have a good place to start when it's going through the induction seal. There are some ways to accommodate for that. They tend to be a bit more custom designed solutions at that point, but certainly something you can do if your package requires a non-threaded closure.
Yeah, and I'll just another comment. The dairy industry has used snap-on caps for a long, long time, and they rely on maintaining proper tolerances between the critical dimensions of the bottle and the closure, and also with the lining material. So it's been done for many, many, many years, and it can be done successfully. The other part Ryan kind of mentioned, there are applications out there that use some form of a pressure belt system to apply pressure to compensate for that lack of pressure. So the pressure belt comes in contact during the induction sealing process to compensate for the lack of torque.
Question, how much time to cool before retorquing?
As long as possible. So as I said, you really want to give the foil, the heat seal film, and or the wax an opportunity to cool completely. We'd like it as far down line as possible. And it would be different if it was a hot fill application versus a cold fill application. But generically, just as long as possible. And if you want to talk about it in more detail, we can talk about your specific application. Just reach out to me, and we can talk further.
Is it possible to seal very small containers with less than 20 millimeter diameter caps?
Oh, you certainly can. That is going to be an application that we'll go ahead and we'll look at our fleet of deep tunnel sealing heads. We've got a variety of them for different diameter closures. They get a little bit more tricky because you don't have, a large mass of metal to couple into, but certainly something that we can do and do every day. I can think about some small travel size packages of shampoo that we do, maybe baby oil that we do, and those are some pretty small, certainly 18 millimeter, maybe even smaller than that. There might be some 14s that I can think of. So certainly if you've got an application, we can take a look at it and see what we can do for you.
All right, we'll try to get to a couple more questions here. If the end user changes the liner in use, maybe it came from a different batch or it's a different material. If there's any differences in the specifications, do you recommend revisiting the induction sealing window?
Absolutely. If you've got any change in materials that is a variable in your process that you're going to want to make sure that you look at. And really setting up that operating window can be it can be as simple as a 5 or 10 minute process. So it's something that we really recommend if you're changing materials. Every time you set up, just, if you've recorded it, go back and verify it. It might not be a long process, but something that you certainly want to consider redoing with any changes in your materials, line speed, whatever it may be.
Yeah, I agree. It's important to note that if you change bottle suppliers, closure suppliers, if you change resin, if you change liners, you really have to start from scratch and go through that setup process and document that window. Any change needs to be revalidated.
Question for you, BJ. Is there a life to induction material being stored?
Well, there's a recommended shelf life, or there's an established shelf life for all lining materials. They can vary from one material to the next, but generally the shelf life of the material is 1 year from the date of manufacture, which would be 1 year after the date the material ships, leaves the building. Take that one step further, we recommend FIFO be used, but certainly material should be used within 1 year of shipment.
All right. Our final question, kind of a summary from many people, talking about ways to verify a good seal and what is the state-of-the-art technology that's out there to help packagers do this.
It's a question we get quite often, Mark. Really, you want to look at all of the things that we talked about today, making sure that you've got quality materials, you've made the right equipment selection, you have consistent, proper application torque, you've set up your machine consistently every time, and then adding in things like high cap detection, stalled bottle protection. Those are things that you can do very easily and inexpensively to ensure you get a perfect seal every time. Those are some really easy steps to take. Validating, doing random sampling is another piece you probably want to put into the equation. Think about any good process that you design. If you put those things in, you're going to eliminate or minimize the chance of a failed seal. And one of the questions we get on top of that is, well, what about some sort of verification or an additional inspection system after something's been induction sealed? There are a number of folks out there who have kind of thrown an infrared camera at this with some level of success. There's certainly some success that you can gain. What we've seen so far is it may detect gross failures, but probably gross failures that you could pick up in other ways. The cost of systems, what we've seen so far, there are some folks who have taken systems and loved them, others who haven't. I've seen them range anywhere from $50,000 and $100,000 to $250,000. And I think the real key there lies in camera technology. We might not be there quite yet on affordable camera technology to make a seal verification system realistic for what most people are looking for. But it's really a matter of setting expectations. What are your expectations? If you expect it to pick up any sort of minor variation in seal, it's if you can find a system that works, you're going to be in the hundreds of thousands of dollars in all likelihood for a solution, and that's a decision that you'd have to make. And is it right for your business?
And I'll just make a comment. Visual inspection is obviously very common. In addition to the infrared cameras, a lot of fillers set up burst tests or peel strength tests or vacuum tests. Again, it's an insurance policy to verify, package performance, but it seems to be unique to the brand owner or the filler.
All right. Thank you, BJ. Thank you, Ryan. I'd also like to thank our audience today. Great questions. There's more for us to get to. Again, teams from Sealig and Enercon will follow up to make sure your questions are answered. You can also reach out to BJ and Ryan directly with their contact information there. Again, within 24 hours, you'll receive access to the presentation recording, also the PDF of the slide deck, as well as the handouts that we mentioned before. We appreciate your time you spent with us today, and we look forward to seeing you at our next webinar. Everyone have a good day, and this will conclude today's webinar.
Thanks, everybody.